put it all together into one graph of a continuous f of x, well, not a continuous f of x. As x approaches 2 from the positive side, the function heads to infinity. So I say, well, there's going to be a place called x equals 2 on the graph, and as I approach 2, the function has to go up to infinity. Okay? Now, when I read this second statement, it says, as x heads to 2 from the other direction, the function is headed where? No, not this way. That's x equals negative infinity. These are x's over here. These are y's over here. So my y values are headed to, that's the direction to point the finger. All right, so then down there. Okay? So what's happening at 2 then? If on one side of 2 I'm going like this, and on the other side of 2 I'm going like this, I have a vertical asymptote at 2. Okay. Then I read this piece of information, and here's your x heading to infinity. So as I go that way, the function is headed towards 1. So there's this line, y equals 1, and this function is headed down to that line. And then over here, as x heads towards negative infinity, the function is also heading towards 1. So I'm heading to the same horizontal asymptote, but I'm not coming down from the top like I did over here. I'm coming up from the bottom, like that. Yeah? Okay. Any questions about this? Yeah. These are telling me about a vertical asymptote. These are telling me about a horizontal asymptote. Remember, horizontal asymptote is always at the extremes in our domain. Negative infinity, positive infinity. Where's the function headed? Okay, great. Any questions for those of you who got to the correct worksheet for last night? Any questions from any of these problems? I'd like to practice more of these today before we start exponentials. But I know that some people did work on this, so I do want to take questions. Sir? One B, D. Okay. You know, the denominator has an x squared and a plus, so I know there are no vertical asymptotes. There sure is a slant asymptote. Yep. Did you put the 0 placeholders? Throw it away. Just throw it away. Do you need me to go further? Yes. Who said yes? Okay. So what do I multiply this by to make that? How about a 2x? 2x to the third plus 2x squared. And I subtract, I get negative 2x squared. What do I multiply this by to make it be this? I get a negative 2. So Grant, I'm going to stop right here and say that's my slant asymptote because all the rest is going to be remainder. I just need the equation of the line. Did I make a mistake? Should I do it again? What did I multiply that by? Okay. All right. Helena, yes? And now the graphing of that? Okay. But you said keep going. Okay. Anyone need me to go further with D? Okay. Yes. To F. Find the formula for the inverse function. Okay, so can you give me what you came up with for A of x? $30,000 plus 3x over x. So there's the cost, the total cost of making x objects. And the way I find an average is to take the total and divide it by how many objects. And that's what you've done here. Great. And now I need to find the inverse of this function. All right, so, and we could call that y. We talked last year about when we do inverses, and you may or may not have been here for this part of the conversation, we normally switch x's and y's and solve for y. The problem with doing that in word problems is that sometimes the notation can mislead us. So before we go any further, my original function, I plug in a number of units and I get out an average cost, right? So input units, output cost. So what should be the case with the inverse of this function? Right. And so if I switch x's and y's, it's kind of funny, x's and y's, 30,000 plus 3y over y. I'd multiply both sides by y to clear out the fraction. I'd subtract 3y, yx minus 3y equals 30,000. And then I would factor out a y, x minus 3. And then I would divide to get y by itself. So 30,000 over x minus 3. And so we would think this were the inverse function, right? Because we switched x's and y's and we solved for y. But remember, you told me that x represented the number of units and that y represented the average cost. And you told me that with the inverse function, I should be plugging in an average cost. But isn't that the symbol that represents number of units? Right. So that's a little freaky and upsetting. And so we said, yes, we'll switch the x's and y's every time, whether it's a graph, a table, some algebra, except word problems. And with word problems, what we're going to do is not switch the x's and y's. We're just going to solve for the other variable. So if I hadn't switched the x's and y's and I just solved this equation so it said x equals, I would have yx minus 3x equal, I'm solving for x, right? Yes, because now I have y, now I want to solve for x. Equals 30,000, and I factor out an x, and I have y minus 3, and so x equals 30,000, y minus 3. And in my brain, this makes a lot more sense because now I'm plugging in that average cost, a number slightly bigger than 3, and subtracting 3 from it, and taking the fixed costs and dividing by that number to get the number of units. Okay, it's a strange way to figure out how many units did we make? By checking the average cost. Okay, any questions about that one? Okay, any other questions from this worksheet? Okay, fabulous. Kaylee said, Mr. Kuklik, can we have extra time on this worksheet because some of us didn't get it? And sure, that's fine. I don't really care. You know, whatever you need to be successful. Okay. All right. But there's new homework tonight. I hear it's bookwork. All right. Okay, so I want to go back and do a couple more of these wacky graphs. Okay. So let's introduce the notion of concavity. We didn't talk about concavity yesterday in our problems, did we? No, I didn't think so. Okay. You'll love this. Okay. In fact, I think I should write it over here. Okay. F of 0 equals 1. As x heads to infinity, f of x heads to 0. As x heads towards 2 from the positive side, f of x heads to infinity. As x heads to 2 from the negative side, f of x heads towards infinity. F is concave down on negative infinity to negative 2, concave up on negative 2 to 2, union 2 to infinity. F is increasing on negative infinity to negative 3, union negative 1 to 2, and f is decreasing on negative 3 to negative 1, union 2 to infinity. That's a mind-boggling amount of information, Darity says, and it all helps me graph f of x. We need to, like yesterday, clarify perhaps some notation and come up with some understanding. So concave down. Concave down is frowny face. Concave up, smiley face. Okay, yeah, but no. But sure, exactly. Just exactly like that. Just not anything other than the shape, though. Okay, good. All right. I also want to say, you know, we can be a little more precise with our drawing and say something that looks like this shape is increasing and concave up. Something that looks like this shape is increasing but concave down. Something that looks like this shape is decreasing and concave up. And something that looks like this shape is decreasing and concave down. These are the most common things that we will draw. Some students, Kaylee, find it really useful once they get past this first block of information that is reminiscent of the bell work problem. Some people find it useful to make some number lines and put some values like negative 3, negative 2, negative 1, 0, 1, 2. Do we go past 2? Just to infinity. Okay. And then they make one dealing with increasing and decreasing and the other with concave down and concave up. So let's process some of that information. Concave down on negative infinity to negative 2. So I'm concave down, I'm concave down. Concave up on negative 2 to 2 and 2 to infinity. Concave up, concave up, concave up, concave up, concave up. Increasing on negative infinity to negative 3. Increasing, negative infinity to negative 3. The function should also be increasing from negative 1 to 2. So increasing, increasing, increasing. But from negative 3 to negative 1, my function is decreasing. Decreasing, decreasing. And from 2 to infinity, my function is decreasing. So I got a lot of information. But look, now what I've got. Increasing and concave down. Hey, I know increasing and concave down looks like that. So I'm thinking that this portion of the graph looks like that. Okay? Let's take a look at this first part before we go any further with that. F of 0 equals 1. What am I learning because f of 0 equals 1? Ben? Of at 0, because y-intercept. Okay, good. And then, Kaylee, what about this one? As x heads to infinity, f of x goes towards 0. As x heads towards infinity, the y values are headed. So maybe this, or maybe this. This is all about a horizontal asymptote. As x values head towards infinity, the y values are going towards 0, or the y values are going towards 0. Okay. As x approaches 2 from the positive, the function heads to infinity. As x approaches 2 from the negative, the function heads to infinity. Catalina, what can we say is happening at x equal to 2? Vertical asymptote. Okay. So let's see if we can put a picture to all of this. We know that we have a vertical asymptote at 2. Oh, I've got a lot of stuff over here. Sorry, I'm going to move this vertical asymptote a bit. VAX equals 2. I also know that I have this horizontal asymptote, at least on one side, as x heads towards infinity. So y equals 0. All right. And over here at 0, Ben tells me I have a y-intercept of 1. Any questions about using these top 4 pieces of information? Oh, thanks. I haven't used all of them, have I? Thank you, Mr. Rayo. So Mr. Rayo's look at me said, but don't you have to be approaching infinity on both sides of 2? I was very observant of you. Thank you for engaging with the problem. Good. Now, are there any questions with this? Okay. All right. So I've gotten through all this information here, and I'm ready to start dealing with this. And my recommendation for dealing with these 4 pieces of information amounted to make this table, and now use this table. When I'm increasing and concave down, I know looks like this. But let's check out over here. We've already got part of the graph drawn. Let's see if this is consistent. From 2 on, I'm decreasing, but smiley face, concave up. Is that what this says? Decreasing, oh, and concave up. How convenient. I just naturally drew headed towards infinity that way. Okay? Question? Okay. What about on the other side of 2, like from 1 to 2? Is the graph increasing and concave up? Nice. I'm increasing and concave up here as well from 0. So, whoa, and back here all the way to -1. So I need to be concave up and increasing from all the way back here at -1. So I think I'm going to have to redraw this piece a little bit because I need to be going, you know, up. Concave. I kind of need more. I need more space up there. Because what do we know? We know that we're supposed to head towards infinity here, but we're also supposed to be concave up and increasing through this point. So this takes me to -1. Okay, what about between -2 and -1? Decreasing and still concave up. Remember, decreasing and concave up looks like this. So if I draw that in, decreasing and concave up. What do we have at x equal to 1? Couldn't hear you. Do we have a minimum or a maximum? A minimum. And I know we have a minimum because my graph goes from decreasing to increasing. When I go from decreasing to increasing, I have a minimum. Okay. So this is minimum. Don't use that same symbol. All right, so what about from, sorry if this is -1. What about from -2 to -1? From -2 to -1, my function should be decreasing, my function should be concave up. Oh, so I'm just going to continue decreasing and concave up. But then I get to -3. And what happens at -3? Now I'm supposed to be increasing. Oh, I'm sorry. I'm supposed to be still decreasing, but I'm supposed to be concave down. decreasing and concave down. There's negative 3. We call this point where we switch from concave down to concave up. We call this point an inflection point. We will spend a lot of time not just finding maxes and mins, but also inflection points where we change concavity this year. Any questions about negative 3 to negative 2? Okay, now we're going to look on the other side of negative 3. According to our little table down here, on the other side of negative 3, we're concave down, but we're not decreasing, we're increasing. So increasing and concave down looks like this. So I need to draw that shape here. Increasing and concave down. Hey, what did I have on the graph at negative 3? Can't use that notation. I had a maximum. When my graph goes from increasing to decreasing, I get a maximum. When my graph goes from decreasing to increasing, I have a minimum. And when I change concavity from concave down to concave up, here I have an inflection point. Any questions about putting all this information together? If any of you felt like you could do one of these on your own right now, I'd be amazed and surprised. Let's do another. I do want to ask the question, though, before I erase. Was there anything about what I just did that you need me to speak on again before we look at the second one? Yes. Concave up, concave down, increasing, decreasing. So I think of this, and you might have heard the phrase graphic organizer. Let's use a graphic organizer to help us organize our information. I find this to be a useful math graphic organizer, where I'm taking the information about increasing and decreasing and taking the information about concavity and trying to line them up so that they make sense. Because when I read that information over here, this has negative 3 and this doesn't have negative 3, and I'm already more confused. But if I can come over here and look at every single integer value and describe whether I have increasing or decreasing or concave up and concave down, then I can think about the graph simply being bits of shape that I will glue together. Okay? Any other questions before we try another? Okay, let's try another. Because you've got 2 on your worksheet. And yes, this is definitely fair game for the Chapter 1 test. Okay. As x heads to negative infinity, f of x heads to negative 1. F of negative 1 equals 0. F of 0 equals 12. As x approaches 2 from the negative, f of x approaches negative infinity. As x approaches 2 from the positive, f of x heads towards infinity. F is concave down on negative 3 to negative 1, union 2 to infinity. Concave up on negative infinity to negative 3, union negative 1 to 2. We have increasing on negative 2 to 0, and we have decreasing on negative infinity to negative 2, union 0 to 2, union 2 to infinity. Lots of bits of information. I'm not going to, you're done with this though, right? So I can clear this space, right? That's all I'm going to do. Okay. Can we say anything about any asymptotes? Megan? There's a vertical asymptote at x equal to 2. Okay. Can we say anything about any horizontal asymptotes, Megan? On the left side of the graph, we seem to be approaching -1. So I have a horizontal asymptote on at least one side. And I don't know what's happening over here in the positive land. This then tells me is a, but what's this then? An x-intercept. So they've given me an x-intercept at -1 and a y-intercept at 0. I find these to be nice little anchor things to plot on my graph as I try and connect these curvy bits. Okay. And Chloe, I'm going to make my little increasing, decreasing charts. We want to go -3, -2, -1, 0, 1, 2. Do we have 3? No. And then concave down, concave up. In fact, maybe I'll just make it one chart and put increasing and decreasing on top and concavity on the bottom. Okay, so what do we know about increasing? Increasing from -2 to 0, increasing, increasing. Decreasing from -infinity to -2, decreasing from 0 to 2, and decreasing from 2 to infinity. I've got concave down, concave down, concave, no, concave down here from -3 to -1, also from 2 to infinity. And I'm concave up from -3 to -infinity to -3, and concave up over here, and over here. And again, I want to think about those 4 shapes that I can have: decreasing and concave up, decreasing and concave down, increasing and concave down, increasing and concave up. Okay. So we graph. 0. Horizontal asymptote. Horizontal asymptote we said over here would be -1. We have a y-intercept located at 12. We have an x-intercept located at -1. -1. And do we know anything else? Oh, vertical asymptote, Megan told me, at 2. Okie doke. Any questions so far? Okay. Try drawing. What's happening from 2 to infinity? Concave down, decreasing. Concave down and decreasing looks like this. So my graph is supposed to be concave down and decreasing. I have no idea. Oh, wait a second. Concave down and decreasing, but how can with the hold that thought. Oh, yeah, I read it wrong. This one goes over here. I know. But we're a redemptive society, aren't we? Okay. No. What? I just moved that in the wrong place. I'm sorry. Oh, I hate my life. It was like that. 2 to infinity. What's the... I want concave up from -1 to 2. There we go. That's where my issue is. Concave down, concave up, -3 to -1, concave up from 2 to infinity. Oh, I switched these. That's what it is. Concave up, concave down. Yep, we can. Sure. I hear the beaches in Barbados are beautiful. We could even have a song. Per spellman han hade ein einaste ku. Per spellman han hade ein einaste ku. Han bytte bort kua, fick feila igen. Han bytte bort kua, fick feila igen. This is Norwegian. Okay. There. We've cleansed -3 to -1. I changed the concavity. -3 to -1, I'm concave up, and 2 to infinity, I'm concave up. Okay. And then I'm concave down over here, and concave down, and concave down, and concave down. And from 2 to infinity, I'm decreasing. Okay. Let's try again. We've had our cleansing Norwegian song. Decreasing and concave up. Feels better now. Decreasing and concave down. Decreasing and concave down. Decreasing and concave down still. What did we say when we changed from increasing to decreasing would happen? Maximum. Notice on the other side of 0, increasing and concave down. Increasing and concave up, which means here at -1, I have an inflection point. Increasing and concave up, good. Oh, look, decreasing and concave up. What did we say would be the case when I go from decreasing to increasing? A minimum. And then over here, I'm decreasing and concave down. And so I have another inflection point here at -3. Oh, but what's wrong with this graph? Well, there is only one asymptote, but that's, what about this? Wasn't I supposed to end up as x heads toward -infinity, f should be approaching -1? So I still have that inflection point I was talking about. I'm still decreasing and concave down, decreasing and concave down. I just had to drop my graph lower so I could achieve this horizontal asymptote from below. What? Where I change concavity from concave up to concave down, or concave down to concave up. You've actually seen them a lot. For example, y equals x to the third, where I go from concave down to concave up, has an inflection point at 0. And y equals cube root of x, where I go from concave up to concave down. Those have inflection points. Okay? Okay. I feel like you have enough now to do those problems on the bottom of the worksheet. I'm not saying they'll be easy, but I know that you can do them, and it's good to think a little bit each day. I want to spend a few minutes talking about exponentials because this is our review time, and it's good to review things rather than just Kukla assumes that I remember it all. So 20. Time 1950, 1970, 1990, 2001. We had 13.6 13,683,000 people living in South Africa. We had 22,502. We had 36,794, and we have 44,819,777. Population seems to be growing, getting bigger and bigger. In this 20-year period, it's about 9 million. In this 20-year period, it's about 14 million. So it's growing faster. And then I only have a 9-year period, so I don't want to make any conclusions about that yet. But 8 in the first 9 years suggests that I'm on track to be growing even faster than I was in the previous 20. Okay. Will you use your graphing calculators to build an exponential regression model for me? Oh, please make t equals 0 in 1950 so that we can all talk. I guess I have to turn that plot on. Exponential, because we're growing faster and faster. I didn't because of that last data point. I didn't want to round it. I did not. I put all the numbers in. My units are ones. Your units, you're suggesting, want to be millions. I did not type in 13.683. I typed in 13683,000. Okay. below ln. Thank you. Okay. Question? Okay. Do you have a graph? Sweet. Any questions? Did you type the data in? Turn the plot on and do zoom stat. How's it going? Okay. Goes up. There it is. You might want to store the regression equation in y1. Yes, please. This looks perfect. This looks perfect. Did you do zoom stat? Number 9. Just press 9. Did you type the data into the stat list? Oh, then turn the plot on. Plot not on. Okay. Is graph? Nice. Graph? Mine's only showing 1 point, Mr. Koopa. This sucks. I like 50 and 61 aren't correct. 2001 is 51. But that's only part of the issue. Then go to y equals and make sure the plot's turned on. That's beautiful. And then do zoom plot. Or stat plot, rather. How's it going? That's beautiful. How's it going, Cannon? And then, yep. Okay. And you don't need those other plots turned on, just plot 1. Okay. Okay. So we can do this? Okay. Can we build it by hand? Why would it be hard? Well, if I'm going to, I mean, it's P. Well, if I make this T equals 0, isn't this number going to be my P in PERT? And then I just use another ordered pair to help me find my R. So will you do this by hand? Since we're using PERT and your regression didn't use PERT, don't be surprised if you get something that the numbers don't look the same. When we graph in Y2, this new model, they should be pretty close to the one that we asked the calculator to come up with as a regression. Okay. I think there needs to be a negative there. Any questions? Yeah. Yeah, I did. By 20. Oh, I divided by my p-value. Then I took the natural log. That allowed me to bring down the 20r. And then I divided by 20 to get r by itself. Graph it in y2 and see how close a match it is. Hey, Kaylin, how's it going? Cool. Can I see both graphs? Nice. I don't know. I left mine like that because I was too lazy to type it all into my calculator. But I see mine's pretty close match. How'd it go? Uh-huh. Right. Yeah. Splits the difference. Yeah. And that's the cool thing about regression is that it's trying to plot the one that has the course that's closest to all the points. Mm-hmm. Any questions, Kaylee? That was a beautiful sing-song. That's great. Any questions? I'm sorry. I mean, T is what? It's just T. I just have a T there for mine. See? T. Or X. That's the regression one. Okay. And then here comes yours. Oh, that's nice. Whoa, look at that. And mine looks like that too. Okay. Great. All right. The last thing I want to talk about is half-life. Does anyone remember the shortcut for half-life? Q equals Q sub O e to the kt. Half-life K shortcut. You know, if I tell you that the half-life is 12 days, that tells me that Q equals half of the original amount when T equals 12. And I can go through this process of plugging those values in. 1/2 Q sub O equals Q sub O e to the k times 12. And then I'd divide both sides by Q sub O, and so I'd have a half here. And then I'd take the ln of both sides, and then I'd bring this down, and I'd end up with k equals ln of a half, because we're talking about half-life, divided by 12. Yes. Yeah, say when. I mean, I'll show you, but I would, yes, I would really like you to use the shortcut. So what is the shortcut then, Brendan? K equals the ln of, always for half-life problem, divided by time for half-life. So that always gives me my K. The rate at which the isotope decays. So in the last problem, we had something like a 2.3 population growth because our R was 0.023. And in this problem, well, I don't have a problem, and I think I'm a little stuck for time for a problem. I could give you a problem. Scroll down a little bit. Okay. So if I knew that the half-life was 30 days, and I started with 5 grams of a substance, I could come quickly to writing the equation Q equals 5e to the ln of a half over 30t. And so there I have my model. And now I can answer a question like, hey, when will I have 1 gram? And will I put a 1 in here or 1 in here? Q, quantity. So 1 equals 5e to the ln of a half over 30t. Hey, remember, don't round in this class, especially these R or K values. Run them out to 9 places. Let your calculator carry this. Just type this in. Don't do the decimal rounding thing that some students do, because often they get the answers wrong. So we'd have ln of a half divided by ln of a half over 30. Oh, I'm sorry, ln of a fifth equals t. We'll be doing more with exponentials on Monday. You've got exponential bookwork this weekend. Some people are working more on the worksheet. I'll take questions on both assignments Monday. You have a fabulous weekend, Stephanie. Take care. Bye now. Take care. Bye now. Take care.